Great.
Okay, let's move right along to our last talk of the session, which is Michael Hanus. And Michael, are you ready to go?
Yeah, so.
Great, thank you.
Okay, so thank you very much. I hope you see my slides. And yeah, basically this is a position paper where I want to argue for a more set-oriented view of logic programming. And it is motivated by the gap between theory and practice. So in the theory of logic programming, a program is considered as a set of rules, and the operational semantics is a LD resolution. And we have also the nice completeness results if we assume a fair search through the search tree. But on the other hand, it is not a universal programming language because there is no concept how to do I/O. And really, by universal, I mean I can write application programs where I can ask the user for input, I can read from files, I can send packages through sockets and so on. And this is not covered by this. On the other hand, this is a good thing about Prolog, which is a practice. So it is universal because we have predicates doing I/O and so on. And these predicates are, yeah, they do, these predicates do somehow some side effects. And this requires also that a program is a list of rules. So we have to know the order in which these side effects take place. And therefore the operational semantics more restricted. We have LD resolution, and in basically it is backtracking where the list of rules comes into place. And the disadvantage, well known, it is incomplete. And this complicates also teaching and reasoning and so on. For instance, here we have a simple definition of piano numbers. And if you have just this order of rules, then you get in Prolog no results if you ask for a piano number. And I think a set-oriented view of logic programming can fix these things, because in this view, the basic idea is the order of non-deterministic choices is not fixed. So this is also an advantage because then the implementation can choose an appropriate order, for instance, in order to ensure to have a complete search strategy in order to really find solutions. But on the other hand, this prevents side effects, because how we do I/O if we do not know the exact order. And if we look, for instance, in the functional programming community, they also have the same problem, but they have found an interesting solution to separate declarative and effectful computations, also by the type system, which is basically called monadic I/O. I do not want to go into details about this, but here, this means for the effectful computation, we can specify a particular order, and the rest of the computation can be done in any order. And therefore, I think the solution to close this gap is to combine logic and functional programming ideas. So this gives us a declarative and universal programming language. So, and we have done this. I worked with for a long time on the language Curry. So basically, Curry is a multi-paradigm declarative language. It's a syntactic extension of Haskell. But it's also, in contrast to Haskell, it offers also non-determinism and free variables. And also, in contrast to Haskell, a program is a set of rules, not a list of rules. So that we can also apply different search strategy, and the operational semantics is based on lazy evaluation. And this has also some influence on the search, because then we have also something like a demand-driven search strategy, which is a different issue. But the important point is that the first search strategy is not fixed. So here's a simple example. So the archetype of a non-determinism in Curry is a non-deterministic choice operator, which is defined by these two rules. So that means the non-deterministic choice either returns the first or the second argument. And if we, for instance, define coin should be equal to 0 or 1, then coin has just two values, 0 and 1. And there is no order in which these values are must be produced by an implementation. And I think this order independence or set view is not a problem, but it is really a feature, because query systems are allowed to return answers in different orders. And therefore, it's also discouraged the use of side effects inside, for instance, non-deterministic computations. And the main advantage is that we can build systems which are operationally complete. And for instance, Sprite and Curry2Go are such systems. And in these systems, if you ask, for instance, here loop is a non-terminating computation. If you ask, give me some value for loop or coin or loop, then in these systems, you get the values 0 and 1, in contrast, for instance, to similar Prolog systems. So the advantage of operational completeness is also you can avoid the reasoning on the influence of the search strategy to the success of a computation. But on the other hand, it is also an issue or some complication for the language design. Because if you want to write application programs, an application program is usually a sequence of I/O actions. So you read some file or you read some user input, produce some output, communicate with other servers, and so on. And that means you cannot, for instance, do non-determinism in these I/O actions. For instance, you cannot just say, so I want to read from this server or from that server or close the file and later I want to write to the file and so on. This means that all non-deterministic sub-computations must be encapsulated. So you encapsulate them and return the result in order, for instance, to print run result or a best result or all results and so on. And if it is order independent, then, for instance, the classical find all in Prolog does not work. And therefore, for instance, in Curry, we have we compute this by returning a set of all results. So that means that we have no order of results, and this is implemented in the way for each operation from one type to another, there is an associated set function which takes the same argument, but returns a set of all values which this function would be computed. But it encapsulates only the non-determinism of the function and not the non-determinism of the argument. This is another story in order to get a really declarative meaning of encapsulation. So that means, for instance, the coin operation has a set functions which just returns in a deterministic manner a single value, which is a set of 0 and 1. But the set is basically an abstract type, so we cannot look into the details of the implementation of the set, but there are well-defined operations, for instance, minimum, sorting, emptiness, and so on. And since there is no first element in the set, if we want to select some single element, this is basically an I/O operation, because you may get different results depending on the scheduling of the system. So just to show you something that an implementation of a really fair search strategy is not really does not really add some complexity. Here is a table from another paper, so where we compare Pack's implementation of Curry, which is based on compiling Curry programs into SWI programs, or Kix compiles into Haskell. This was the first implementation offering different search strategy. And our most recent implementation is Curry2Go, which compiles into Go, and it also offers backtracking, breadth first search, and here fast search. And the first search is implemented by compiling into Go routines, so it is also somehow parallel. And then in many cases, if you have a really essential non-determinism in your program, then also the non-deterministic program runs faster than the deterministic ones. Okay, so let me conclude in order to stay within the time. So I tried to convince you, maybe you can think about this, that a set-oriented view of logic programming is useful to close the gap between theory and practice, which is also good for teaching. And it also enforces a higher declarative style, because side effects during search are forbidden because they are meaningless. And it immediately supports also OR parallelism, because if you do not have to think about the order, you can do it just in parallel. And it also, if you have a good implementation, you can also ensure operational completeness. And basically, this is also nothing new, because in a restricted settings, for instance, data log or ASP, you also do not think about the order of rules. And it could be also implemented to strict languages. The final question is whether set or multi-sets are more appropriate. And I think this is just a matter of taste, because sets are more declarative, because then the multiplicity of solutions is not relevant. But multi-sets are easier to implement and then somehow more flexible, because you can return a multi-set of functions, but you cannot return a set of functions, because then you have to solve the equality between sets. Okay, that's all. Thank you very much.
Okay, thank you. Perfectly in time. I'm impressed. Thank you.